Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever with the birds, the classic turn, turn, turn. And we are turning our attention to the cosine rule. So let's get to it, shall we? All right, so there's the cosine rule. A squared equals b squared plus c squared minus 2bc cosine A. And there's a pattern here. If you want to pause it and take a look, it's very easy to see. You have the side length A, then we're going to use the cosine of angle A, and then the side lengths, the other side lengths B and C, are used in the rest of the formula. The formula is the same, it just follows this pattern. And I don't like to give formulas without letting you know that they come from somewhere. And so I'm just going to quickly run through this to show you, where the cosine rule comes from. And it really has to do with the Pythagorean theorem. So we have big triangle ABC, little a opposite, little b opposite it, and then little c is actually this entire length. But what we did conveniently is we called from a to n length x, which makes the length from n to b c minus x. So if you look at triangle ANC, b squared is equal to h squared plus x squared using the Pythagorean theorem. And solving for h, that's equal to b squared minus x squared. Oops, I don't need the minus, it's already there. Subtracting x squared from both sides. Then if I look at triangle BNC, a squared is equal to h squared plus the quantity c minus x squared. And then if I solve for h squared, I get a squared minus the quantity c minus x squared. Okay, so I have equation 1 and I have equation 2. Since h squared equals h squared, then that means that a squared minus c minus x squared, that's coming from equation 2, is equal to b squared minus x squared from equation 1. Okay? And if I expand all of this, if I take c minus x times c minus x, and I move it over to the right-hand side, solve for a squared here, this turns out to be, let me get rid of this big C here so I have room, a squared is equal to b squared plus c squared minus 2cx. You just have to trust me on that. There's a lot of cancellations here, but solving for a squared results in this. But in triangle ACN, see this triangle right here? It's a right triangle. The cosine of A is equal to adjacent over hypotenuse, or x over b. And then solving for x, I multiply both sides by b, and x equals b cosine of A, which I can replace here, right? I'm going to replacing x with x, so that means that a squared would equal b squared plus c squared minus 2c, and replacing x with b cosine A, and I have my law of cosines. If I go down one more step, all they did is switch the b and the c. Instead of 2cb, 2 times c times b, they do 2 times b times c, and then of course the cosine A. So that's what we're going to use here to solve some triangles. Very useful. Okay, when you can't use the law of sines, you can use the law of cosines. So they want to find correct to 2 decimal places the length of BC. That's right here, and that's little a. Okay, and so I know that a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. And before I get through, that's perfect for this, but remember, just to show you the pattern, let's say I needed side B, I didn't know this one, then I would start with b squared, that's equal to the other two side lengths, a squared plus c squared, minus, there's always a 2, times these same lengths, except they're not squared, ac times the cosine of the angle of the side that you have over here, cosine of angle B. And then c squared, same thing. The sides missing are a squared plus b squared minus 2ab cosine, cosine of angle C. All right, so let's do this, shall we? So a squared is going to be equal to b squared, so that's 12 squared, plus c squared, 10 squared, minus 2 times 12 times 10, just replacing b and c here, times the cosine of 38 degrees. Okay, so a, taking the square root of both sides, is equal to the square root of, I'll do a little bit of simplifying here, 12 squared is 144, plus 10 squared is 100, minus 2 times 12 times 10. Well, 2 times 10 is 20, times 12 is going to be 240. Yes, minus 240 times the cosine of 38 degrees. Okay. Now, if you didn't want to do the simplification, you could just take the square root of the whole thing and put it in Desmos. Okay. Now, if you put this in Desmos and you're in degrees, I guess I'll go ahead and show you that real quick. So 144 and 100 and 240. Okay, I hope I don't have to look back. So 144 plus 100 minus 240 cosine 38. So let me get Desmos up here. Okay, and I need to go straight to the calculator. Come on, come on, come on, come on, come on. There we go. Beautiful free math. Sorry. Okay, so first thing I'm going to do is make sure that I'm in degrees. So I'm going to go over to my tool thing, and I'm in radians, and I'm going to be in degrees. So now I'm going to do square root, parentheses, and I've forgotten. So it's 144 plus 100 minus 240. So 144 plus 100 minus 240 times the cosine, and I believe it was 38. Cosine of 38, I hit enter, and I get 7.4 rounded to the nearest tenth. So let's go back here, and A is equal to 7.4. Very simple, very easy. Again, you could have put it in just like this into Desmos if you didn't want to do any of the simplifying. And that's perfectly fine, and you would have gotten 7.4. Okay. One more example, and I will be quiet. Find the measure of all angles of blah. Well, I'm just going to pick, I don't know, let's pick angle B. We don't have to do all of them. Okay. Well, since I'm doing angle B, I'm going to start off with the formula little b squared. Little b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Okay, so I'm going to go ahead and replace what I have. This is little b, opposite B. This is little a, opposite angle A, and this is little c, opposite angle C. So let's see, B. So that would be 9 squared, or 81, is equal to 11 squared, or 121, plus c squared, which is 14 squared. I will tell you that's 196, minus 2 times A times 11 times C, which is 14, times the cosine of angle B. Okay, so 81 is going to equal 121 plus 196 is, let's see, 296. 296 plus 29, 296, 306, 316. So that's 317 minus, I'm going to do 2 times 11 times 14 real quick. 2 times 11 times 14, enter, 308. Okay, so I've got that. Oops. Minus 308 cosine B. And I have to solve for angle B. Now, I can't subtract this, right, because it's with the cosine b. I don't subtract the 308. So I subtract 317 from both sides, minus 317, right? And 81 minus 317, let's go to Desmos just to be sure. 81 minus 317 is negative 236. Oops, I hate when I do that. Boom, I should have hit enter. Negative 236. Okay, so negative 236 is equal to negative 308 cosine of b. Divide both sides by negative 308. Kapow. And I get a negative divided by a negative is a positive. 236 over 308 is equal to cosine of b. And I'm going to move up here to finish. And I'm looking for angle B, so this is where I take the arc cos. Equals the arc cosine, arc cos of 236 over 308. You could also write, you don't have to write out arc cosine, you can do the inverse cosine, same thing. But on the Desmos, it is arc cos, so that's why I always do it. So 236 divided by 308. So function arc cosine of 238 divided by, oh, short-term memory, 236 divided by 308. See, good thing I checked. 236 divided by 308. Bam. 39.98, so that's going to round to 40.0 degrees. So B is equal to 40 degrees. Okay. And I forgot a C in here, arc cosine. All right, so that is it for this video. Hope you enjoyed it. Let's check in with the birds, can we? We'll play them and check in with them. And hope you enjoyed it. And we are... Oh!